Welcome to Python, everyone.
Thank you.
Yeah. Let's do a little intro. I'm gonna introduce myself and then go over the syllabus for a few minutes. Motivate what's ahead in this career. Some folks might be going on to computer science as a career. Some might be doing CIS, computer information systems. Okay. Typically, I do an icebreaker. However, since this is a hybrid class, most folks are watching this on YouTube. So I'm going to skip this icebreaker. The whole goal of today is going to be setting up a development environment. If folks haven't seen the email yet, there's a welcome email that I sent out last week. It has a couple pointers on how to set this up. Basically, all you really need to do is set up your Cabrillo student email, which will give us access to a server called Jupyter Lab. We'll have some time to set these student emails up later. But in short, you're going to want to make sure that on Google, you're going to make sure that on this top right, it's logged into your student email, not the personal one. So this is my actual email right here. My personal one is down here, which you don't want to be logged into. Just to make sure you're logged into a student email. And if folks are having trouble with that, you can look up Cabrillo student email, and there's a little pointer on how to access this. Right, basically, you want to go to the Google login page and then use this handle right here. It's your number at student.cabrillo.edu. We'll have about 15 minutes later on in class to help everyone get set up with this. Okay, so yeah, that's pretty much the whole goal today. Just set up the development environment and go to lesson 1. I think we'll finish lesson 1 and maybe 2 today, actually. Okay. Any questions about the outline so far? Okay, welcome people on Zoom. And yeah, thank you for the folks in person for coming as well. Okay. No questions yet? Okay. Let's introduce myself. My name is Andrew Tack. Most people call me Tack. I'm from a few hours away. I started here at Cabrillo and then got a couple degrees at UCSC. One of them was in computer science and another one was artificial intelligence concentrated in master's. Okay. I have a lot of projects over in Silicon Valley, mainly because I have a lot of uncles that work there and are always asking for help. If anyone's interested in maybe applying to some tech jobs, always feel free to let me know. I can help folks out with interview questions and letter of references. Okay, my current hobbies are building computers and programming AI. That's pretty much what I've been doing this whole summer. Just building stuff. All right, let's move on. Let's go over the syllabus for a bit. There is a calendar here that will show the times I'm on campus. It includes the office hours and the lecture hours. They're also written in this table as well. For folks who want to come to my office hours, I'm actually usually hanging out in the STEM Center. If folks haven't been in the STEM Center before, it's the building 834 right down there. I'm usually hanging out there, helping out other students from other classes. Always feel free to reach out there. I'm also available on Zoom by appointment as well. All right, so if anyone needs a accommodation for some time that's not listed, I'd be happy to meet. Just let me know. Welcome in, welcome in.
Thank you.
All right, the grading here just consists of 2 items, projects and exams. There's kind of 2 categories in the projects we'll see in the course. It's pretty much labs and programming assignments. So, I skipped over something. I skipped over this link over here. Here, let me back up a bit. There is a weekly schedule here in case folks miss some content. The weekly schedule consists of the content per week. It talks about the lessons and labs we're going over. So since we're on week 1, it's going to be, an intro, what is Python. There's going to be 2 lessons. I think we're going to finish these 2 lessons today, actually. They're pretty short ones. And then finally a lab and a project. The labs are typically due at, I think, Thursday. You should have enough to get this lab done by today, actually. So yeah, you have plenty of time to submit this on Thursday. And then this project, we'll talk about this later. This is, I think, is due for sometime next week. Okay, people cool with that so far? A little weekly schedule. Okay. All right. This is a HyFlex class, meaning it'll accommodate live Zoom, recorded on YouTube, and also in person. In my previous experience, most people just watch the YouTube, but always feel free to see me in person. I'm pretty much on campus a lot of the times. Okay. Okay, any questions about the projects, exams, or grading so far? Okay, let me check this Zoom chat real quick. Okay, looks like people are all good. Okay, folks who just came in, we got computers here. Just gotta press the button. So if you don't have a computer, feel free to use those. Okay. There's a couple exams, just a midterm and final. Midterm is on week 8, final is on week 16. There's no required textbook for this class. All of the content is on the Jupyter server. We'll talk about the Jupyter server in just a bit. Okay. Lots of resources, by the way. If folks can't catch me during office hours or the STEM Center also has a lot of computer science tutors. They're pretty much always on the clock. STEM Center comes with a lot of computers and classmates that are working there. So if you are in a math class or physics, chemistry, biology, this is the schedule for all of the tutors. So yeah, always feel free to go there. This, in my opinion, the STEM Center is one of the best places to get homework done, just because you're going to meet a lot of peers that have probably taken this class before. All right. There's also the CTC. Have folks ever heard of the CTC before? Okay. If not, this stands for the Computer Technology Center. It's all the way across of campus. They have lots of computers. They have tutors as well. And most of the tutors there have actually taken my classes before, so they'll be able to help out as well. The CTC also provides lender laptops on a first come, first served basis, and they'll help out with any tech issues that folks might have. Okay, yeah, lots of resources, lots of them. All right. Okay. If you want to contact me, there's a couple ways. I prefer technical questions to be asked on the discussion forum. Now, technical questions means, oh, something is wrong with my program. How do I fix this? Or maybe you're getting an error message. Like, let's say you're doing homework and then there's an error message. It's probably more appropriate to post these publicly on the discussion. The reason why is because other folks in this class may have the same question. But yeah, for private matters or anything else that shouldn't be public, feel free to message me. I prefer email, just because they're formatted a little nicer. On Canvas, there's not a lot of formatting options through the messages. Okay, so that was pretty quick. Are there any questions about the syllabus? I kind of just went over that. Okay, I'll give it 1 minute in case there's any questions. Yes.
Are there any outlets I can connect my computer to over here?
Are there any outlets? I think so. Check under. Yeah, check under. Do you see any? No?
No.
There's some along the walls. There's a couple over there. But yeah, I thought they were underneath us.
I expect to be down in the floor.
Yeah, the outlets might be
In the
hidden.
center.
Oh, I see it now. Yeah, there is. Thanks.
Okay, cool. Okay, sure there's no questions on the schedule? Okay. All right. Let's move on then. Okay, quit all these. Okay, let's do a bit of motivation and then move on to setting up our development environment and then go on to the lessons. So let's motivate this. This might be people's first computer science or computer informations class. So let's talk about what the future can entail. My background is actually mostly in data science, artificial intelligence, and machine learning, which all kind of overlap with each other. So we're actually probably going to have a couple projects on this. It's going to be towards the later end of the semester, just some data analysis. So given a large data set, you can predict some things based off of it. This is also a very trendy topic nowadays too. Very trendy. Let's move on to some other topics. So AI is actually kind of an umbrella term nowadays. In my opinion, I think the most popular term for AI is probably like a large language model. A large language model is kind of like a chat bot, or something you talk to. Like ChatGPT, that's a large language model. But AI has a bunch of terms underneath it. It could mean autonomous vehicles. It could mean reinforcement learning. Reinforcement learning is pretty cool stuff, actually. It's pretty much training an agent to get better and better over a series of generations. If folks have ever seen the Super Mario that beat the world record, has anyone ever seen that? Super Mario? Okay. There is an agent that plays Super Mario, and it's pretty much trained through reinforcement learning. Meaning it'll play itself like a million times, and then throughout that million times, it'll get better and better through kind of trial and error. So yeah, that's kind of an AI thing as well. We also got image recognition. This is kind of like taking a picture of something, and then it'll kind of label it based off what it is. Predicting the future is also an AI topic. Okay, yeah, there's tons of things in AI. Feel free to let me know if folks are interested in any of these stuff. Okay. Folks might be interested in game programming. Maybe you want to develop the next best game, an indie game or a AAA game. You might be interested in writing non-playable characters that will play inside of that game. Or maybe you're interested in generating content like maps, levels, terrain, any of those. Okay, what else does computer science and computer information systems entail? We'll touch some of this in class too. Maybe you're interested in writing websites and web applications. All right, in this case, full stack development means that we're putting together the front and back end. Front end are for folks who are making the user interface, making things look nice, clickable. We got the back end here too, which is focused on the server side, making sure all the technical aspects are working. This way the front ender can do their job. In a few weeks, we'll have some programming projects that will be dealing with this. So it should be some cool stuff. Folks might be taking this class for IT work, right? Like maybe you're interested in maintaining servers, maybe you're interested in plugging in wires for data centers, or even cybersecurity. You want to protect these systems. Okay. Might be interested in robotics as well. If folks haven't seen this picture on the right, it's Arduino Uno. And you can pretty much program things using these pins right here. So there's some pins here. You can plug hardware into here and control the hardware by writing programs. I teach a class on this, by the way. It's called CIS-15. So feel free to let me know if you're interested in that. Okay. Folks might be interested in this class because of money. You could make a Santa Cruz living wage with any of these. This is the nationwide median annual salary, by the way. If we were to look at the median for a 100-mile radius, it's probably going to be higher. Okay, people cool with that motivation so far? Okay. Folks might be wondering, why is this a requirement for my degree? Like, it might not seem like programming it will fit your degree, right? Some folks are taking, maybe electrical engineering, or maybe they're doing some other major that might not really require programming. The reason why this might be a requirement for many majors is because we'll gain some meta skills from this, right? Meta skills meaning essential skills that will help generally in life as well, such as problem solving. The majority of these programming projects and content will consist of a problem and writing an algorithm to solve it. One of the challenges in this class is probably algorithmic thinking. This is the ability to organize your thoughts into a series of statements that a computer can run. Okay, there's going to be some creative exploration as well. This is also a skill we'll gain. Creative exploration can come from troubleshooting. You might have errors in your program, and troubleshooting will pair up with creative exploration. Okay, hopefully people are kind of getting a sense of why programming is kind of good stuff. Okay, any questions about this motivation stuff so far? Okay. All right. I'm leading a couple research groups, by the way. If folks are interested in university research labs, feel free to let me know. I'm working with a couple professors there, and the whole point of this program is to pipeline students into undergraduate research labs. So yeah, let me know. This is to help strengthen your applications, or maybe you want to meet more peers at the research. Okay, let's see. I'm going to skip over the CS history. It's basically going through the past 300 years and kind of defining what a computer is. I usually use this slide in my other computer science classes. But since this is a CIS course, I'm going to kind of skip over this. Okay, yeah, there's a bunch of history here. Basically, computer used to be an occupation, right? Like a human computer. Your job title would literally be computer. And then fast forward a bit, one of the first computers was the size of a room. You could check this out on Wikipedia. It's pretty much a very large computer. Okay. And then fast forward, a lot of us see a computer as an AI, which once again can be an umbrella term for self-driving, large language models. Okay. Let's move on to the development environment. So before I introduce this Jupyter lab, we need to set up our student email. So So I'm gonna take like a 15-minute break and help out folks in person and on the Zoom to set up the Cabrillo email. The reason why is because this server requires a student email. So if you don't mind pulling up the email that I sent up a week ago, it's a welcome email. There's going to be a couple links that might help with setting it up. But basically you're going to want to look up. The end goal is to make sure that you're logged into your Cabrillo email on the right? Not the personal one. So I'm just going to load up the Cabrillo tutorial for that. Cabrillo College Student Email. Okay, there's an article on how to access the Cabrillo student email. Okay. Yeah, so basically you want to go to the Google login page, which was what I had earlier. Right, Google, and then click on the top right, and you can go ahead and add an account. Right, so click on show more accounts, and then add an account there. Okay, and then the handle we want to use is your ID at student.cabrillo.edu. Okay, it's going to be the same login as your Canvas. Okay. And then once you're all logged in to the Cabrillo student email, you should be able to access this server. It's called jupiter.cis.cabrillo.edu. All right. But once again, before you access this server, make sure that Google is showing the Cabrillo email. Okay, I'm gonna put a 15-minute timer here and help out folks on Zoom and in person. Yes, be right there. All right, let me pause the recording here. Okay. 1 second. Oh, okay, I can't pause the recording. So if folks are on the YouTube recording, you can just fast forward 15 minutes. Okay, and if folks are on the Zoom, feel free to put something in the chat, or we could screen share later. Okay. Okay, yeah, that's all.
Yeah, I signed in a little late, so I didn't get the email he sent.
Okay.
And logged in though.
Okay, you're logged into the, is this the personal one?
This is the school email, but I'm also logged in my personal email.
Okay, okay. And you should be set up then. So you could probably just go to the Jupiter.cis. Oh, sweet. I'll see you. Listen. No problem.
Thank you.
Yeah. Yes, sir. How's it going?
Logged into my student email.
Cool, cool. You should be able to access the server now. It's Jupiter. Oh, I don't have it up there. Just type in Jupiter. Oh, over here actually. I'm gonna say the URL. Oh, no, in that address bar. Like that.
Which one?
I was doing a new tab. It actually doesn't matter. But yeah, just type in right there, Jupiter. Yeah, .cis. .cabrillo. .edu. Say that again?
Where am I going? I did not get the email.
Oh, it's all good. It's all good. Let's see. Which computer were you using? This one?
You know what? Let's use mine.
All right. So we're just gonna log into the Cabrillo email. You can actually just go to google.com. And there should be a button somewhere. Yeah, google.com.
Oh, yeah. I forgot what the, what?
Got you. Oh, I'm not sure which one this is, but our official one is on secure.net.
Okay.
Yeah, connect. Yeah, this your student ID number and password. Did you know that this dinosaur is a game?
Oh, yeah?
Check this out. I'll show you real quick before you get connected.
Okay.
So just like this one little thing. Oh, okay, never mind.
Okay, I'll try that sometime. Okay.
Let's see, google.com. Yeah. So let's get logged in. Can we click this top right? Is that your personal one?
Yeah, that's one of them.
Okay. Yeah. Let's log into the other, the real one, so you can add an account later. And then it's gonna be the number.
I'm studying cybersecurity right now. Yeah,
That's
so
that student. That's
I'm
real.
trying to get like the CIS-15 certificate. And
Student.rio.
the X plus certificate, the Cloud Plus, the, what's it called, the CCNA as well. And I got my bachelor's in criminal justice
Right
Just-
now?
last year,
Canvas password.
22 now.
And so it's my regular Cabrillo password?
Yeah.
Okay.
Yeah, originally, but I wanted a more direct path into like the government, one of the three-letter agencies. But ultimately, maybe not exactly what I want to do. I'd really love to work for one of the big tech companies here in the Bay Area. That would be sweet, like especially at like an AI company or like offensive security company. That would be pretty neat.
Oh. Hold up. This is the same one you used for the Wi-Fi, right?
Yes.
I'm not gonna look, but is it correct?
Being one for them.
Oh, I'm not looking.
Oh, no, I don't care.
Penetration testing,
Oh,
Yeah,
it's okay.
offensive security.
Just
I listened to a podcast where the guy.
just be careful. It might get locked out. Tries too many times.
For banks and stuff, they do banks or tech companies. Or surprise them all because the companies like, oh, no, you can't break in. We got
Okay.
that's people doing stuff.
Oh yeah, it's got to be one of the coolest jobs in
Yeah.
IT and cybersecurity.
Yeah.
Yeah, I don't know, that is password.
Okay.
Because that's what I've got as far as what I had saved.
Yeah, and that's the one you use for the Wi-Fi, right?
Yes.
Okay. Let me see real quick. Just the once.
And so my, it's a 005821. That's student upgrade. Let's try it on this machine.
Actually, that's going to make a difference. But the last resort would be to reset it. I'm not sure you're okay with doing it.
Yeah, no,
Let's go forgot password.
Yeah. It's probably going to be quicker.
And then what email is it gonna send this off to?
Probably the. Actually, let's find out. So, I'm not sure if it's going to send it to an email. It might just be right here. So, this is the IT stuff.
It's your tool, so I'm not
Yeah,
like
it's
invested
original.
in anything.
Can you type in your original?
Yeah.
Oh, no, it's for
It's
you.
me?
Yeah, yeah. This is like the IT stuff.
Oh, I'm gonna, it's so hard to find something legit though.
And then you want to trash home, you know, like,
Oops.
something down or something like that.
Yeah.
And you're screwing, you know, depends on when you do that.
Yeah, like, oh, this one's going up 50 million%. I wonder why. I should buy in all my savings.
Where that, it's that website, they're all like unique ones. They're all like, that Trump one, you love it. You can get it legit, or like a dump, or something dump.
I don't know.
I seen a guy invested in that when he came out for like a couple hundred. Yeah. But I don't know, you know.
Yeah. Really hard to tell with that stuff. High risk and high reward.
Yeah.
I just went to Mike Rio. I'm not sure.
Oh, okay. Let me go back to the other website and see who logs in and out.
You try to keep it.
Off to the. Oops. Not .com. That doesn't make sense. Yeah. So you could probably reset over here. And hopefully it works by then.
Wait, you setting up Parker View?
Settings.
Yeah, you go sign in and then you go to Jupyter server.
So we scroll down. There should be a key password somewhere.
These 12 characters, so.
Maybe they changed requirements. That might be why. I'm going to add a few more minutes because the Zoom folks are having some issues. Okay. For the folks who are having trouble logging into the Cabrillo student email, the last resort is to contact the CTC or IT help desk. I believe the CTC has a live Zoom, and they'll be able to help out a little better. Since I don't have any control over the student logins, I believe these people do. So yeah, feel free to go to live Zoom. We'll get you all set up by the end of the week, though. So.
Yeah, I guess my old password didn't meet the present requirements,
Okay.
so it's all good.
Okay, let me see. Well, let's see if resetting it works. How you doing? Yeah, we're just getting logged in. Most people do it. Have you reset it yet?
Yeah, I did, but then I just clicked through zoning, so back on to somewhere. So,
So is it just our Cabrio ID and our password?
Yeah.
Have you listened to Black Diaries?
I've
The
heard,
podcast?
It's working.
no, but I've heard million stories.
Oh, yeah.
Did something.
About that.
did something, where am I at now?
Doesn't look like it did anything.
It's very, very interesting to me.
Have you ever been on it?
Yeah, many times.
Maybe it added it.
You saw like the stuff they
Oh,
found
there it
out?
is. They added it. Show more accounts.
Oh, yeah. It's hard to find that, right?
Show more accounts?
They basically got rid of it. I mean, it's hard to find. And they haven't gotten rid of it.
Well, you been on it before through Tor
Well,
and
it
all?
should
Tor
be
fine,
fine.
right?
So let me go to server.
You have to have like an active.
I have this
hidden
like,
link,
you don't have to
But those are hard to find, especially on the service web.
CIS.
There's one that's like still working, but it's like outdated for like 2 or 3 years now.
Okay. So your account.
Yeah, the crazier stuff you hear about, like
Yeah.
guns for sale, like people for sale.
And like those weird videos? Or-
That would be like extremely hard to
Okay.
find. That's just like so insane that, you know,
Yeah.
Thanks for sticking with
it's
us.
very.
I will say, it's not as scary as it is made out to be.
But they say it is.
Yeah, it's not that scary.
As long as you're not like,
I don't know.
Participating in that
Yeah,
stuff.
like malicious stuff like that. And you won't get like.
If you stuff like that, or- Here's some quick-
okay, talking to the folks on Zoom. Natalie, is everything good for on your end?
Yeah, I fixed it. I'm already logged into the onto the Juniper or Jupiter. Sorry. Can you hear me?
Yeah, can you hear me?
Oh yeah, okay, I can hear.
Okay. Yeah, I said awesome.
Oh, okay, okay, perfect.
Yep. Testing. 1, 2, 3, testing. Okay.
It's kind of hard to log in.
Oh,
Yeah.
forgot the password?
It's not that. I think it's because I think I'm on another user because it just says right here sign in student. I'm doing everything right and it's still not letting me sign into this.
Oh, you're using the Canvas stuff, right? Remember that password?
Yeah, I'm using everything. It should be, but
Does it say incorrect password or something?
yeah.
If you have it stored on your phone, yeah. I'll check it out after class.
It's just the Cabrio. It's just basically your Cabrio info, right?
Yeah, it's the Canvas login. It's whatever. Okay, I'll check your stuff out after class.
Okay.
But you can still get it done at home. So yeah, but yeah, that's an issue for sure. Okay. Let me continue. Okay, let's move on. So it looks like most folks here in person and on the Zoom have gotten this set up. If you're on the YouTube recording, feel free to reach out. Most likely, if you're having troubles with the login, you might have to reset it.
Oh, that's fine.
Yeah. The reason why you might have to reset it is probably because they might have changed their requirements. So you might have to reset it. And last resort, if things don't work out, please contact the CTC. They have a live help desk, live on Zoom and in person as well. And they'll have a bit more control over your login information. Okay, cool. So it looks like most of us got the Cabrillo student email. We should be able to access this server. This server is hosted at Cabrillo, which contains most of the content we need for this class. So I'm just going to type it in right here, jupiter.cis.cabrillo.edu. Okay, there's our environment. Let's talk about what this environment has. On the left side, this is a file explorer. All right, so on the top left, there's a folder button here. It's going to open up an explorer. Hopefully people see a couple folders here, in particular labs and lessons. This is where most of the content is. There are homework programming projects as well. They aren't available on the server. They're going to be delivered via Canvas. So we'll talk about the homework workflow in a bit, but I wanted to introduce what this server is doing. Okay, this is the last time we'll see the slides. So yeah, Jupyter is an environment that lets us program in a notebook style. There's a couple different styles of programming. The traditional programming style is typically, you write a whole text file of code and then you pretty much run it. This is a little different. This is a little different because we're gonna be able to run Python code slowly, right? Like press the play button on small blocks of code at once. All right, so we'll talk about the other style in the probably on week 8. Around week 8, I'll introduce another style of programming. But the current style of programming that I'm recommending is using notebooks. So let's talk about what a notebook looks like. Okay, I'm gonna load up the first lesson. So it's in the lessons directory, and then it's right here, getting started. So I'm gonna go ahead and double click this. There we go. So this is a notebook. A notebook is a file that contains code and text. But by text, I'm talking about like human readable text. Right, so it's a hybrid of both. There's the human readable text here, and we have code cells as well. The code cells will have play buttons that will run small blocks of code at a time. The first line of code I wanted to introduce is something called Hello World. Hello World is actually an analogy that verifies that people's environments are working. In many programming classes, this is the first example. Right? Like in my C++ class, we do a Hello World, meaning code a program that prints Hello World. And the reason why we do that is to make sure that all the installation went fine. Okay, so the first statement I want to introduce is the print statement. All right, we'll talk about what this is in a bit. This is a function, by the way. A function has inputs. Right, in this case, I'm going to put the input inside of these parentheses. Okay, and by the way, a quick tip on typing. I want to encourage that whenever you see a pair of things, they should be typed out at the same time. For example, there's a pair of parentheses and a pair of double quotes. Right? So I highly recommend that the style of typing should be do the pair of parentheses and then the pair of double quotes. The reason why I'm encouraging this is so we don't have mismatched parentheses nor mismatched double quotes. Right? As our programs get larger and larger, you might see yourself seeing more stuff, right? Like maybe print something, and maybe more parentheses here, right? And then maybe some double quotes, and then maybe more parentheses and more parentheses. So yeah, hopefully people, this will make sense in a bit. Anyways, so type out the pairs first, and then for the input, I'm gonna go hello world. Okay. So I'm gonna skip over a couple things, like what do these double quotes mean? We'll see what these double quotes mean on the probably week 2. But you can think of these double quotes as encapsulating literal text. Okay, so back to what a notebook is. It's a hybrid of human readable things and code blocks. These code blocks have a play button right up here. Here's the play button. So I'm going to press play, and we'll see the output of the cell down below. Okay, people cool with this so far? All right. Yeah, that's what a notebook is. You might find yourself accidentally double-clicking on these human-readable text. So check this out. This might happen a lot. Let's say I accidentally double-clicked here. Oh, okay. So this is just what the formatting for the human-readable text looks like. So if you find yourself accidentally double-clicking in here, you can just press the play button. Right? So just press the play button. It's going to render Markdown. You don't have to know what Markdown is. This is just a formatting style. So just press the play button there, and it's going to render it back to normal. Okay. Any questions about notebooks so far? All right. Okay, I'm going to collapse this on the left here. Okay. We just did our first statement, or first function. Statements are run in order, in particular top to bottom. So if we were to have 2 statements, roses are red, and then another statement on a new line. All right, I'm going to go ahead and press play on here. So press play. We should see them in order. All right, a big takeaway of this ordering is because if an error happens in the earlier ones, then the later statements might not run. So let me invoke an error on this first line of code. Okay, so let me just misspell print here. Right, if I were to misspell print and press play, okay, we get an error here. Right, the error is saying, print is not defined, which makes sense. There's no such thing as this function in Python. Okay, but the takeaway here is if there's an error in the earlier statements, the next ones might not run. So it's probably a good practice to test frequently. Right? Test frequently means that when you're building a program, just press play frequently, right, to make sure things are running fine. Okay. So press play there, and there we go. We fixed the error message. Okay, and just kind of going on the errors again, right? What if I were to make an error in this second line? Right. Well, let's see. I'm gonna press play. Okay, there we go. All right. So the first print statement worked, but then the second one didn't. All right. So hopefully people are kind of seeing the order here. Okay. So there we go. Okay. Any questions about order of statements? Okay. Let's move on to something called comments. Comments are things that don't run. You can think of them as text for humans. For example, sometimes you're writing a large program and maybe statements are hard to read. In this case, a comment might help document what's going on. All right, so this comment here isn't really that helpful in my opinion, but at least it demonstrates what it does. Right? Like if I were to print hello world here, right? So just imagine this as a long statement, and maybe you want to communicate to your coworker what it's actually doing. All right, so in this case, I'm going to say, oh, the below line does this. All right, the next line prints hello world. Okay, once again, comments are kind of meant for humans, but they're also useful for debugging. Debugging means to kind of spot an error and fix it. So when you're writing longer programs, it might be useful to disable lines of code. So here I'm going to turn this into a comment. Right? I'm going to put a hashtag here, right? Hashtag in the beginning of the line. This is going to disable the line. So if I press play, nothing is going to show up. Right? These are just comments. Okay. Yeah, so comments will be very useful later. Right? And it's going to be useful for debugging and communicating what's being done. Okay. In Python, there are something called expressions. Right? We can think of an expression as something that evaluates to a value. So let me do some examples of expressions. Right, I'm going to do this one at a time. And there's going to be a large takeaway from this. So I'll get to that in just a bit. Right? This might seem like I shouldn't have to say this, but here, I'll lead up to it. Okay, 5. This is an expression. What does it evaluate to? Well, let me press play. Okay, 5. Oh, I got to scroll up. Okay, 5 evaluates to 5. Okay, that makes sense. Okay, 5 plus 5, okay, evaluates to 10. Okay, that makes sense. I want to lead up to a large takeaway of this notebooks. So one of the products of this notebook is that it'll display the last value of the last run statement. Meaning that if I were to do something like 2 here, right, so let's put a 2 here, and let me press play, see what's going to happen. Right, so I'll press play, and yeah, we see 2. Okay, this is a product of Jupyter Notebook, not traditional programming. Jupyter Notebook will display the value of the last expression, 2. Right, so this is being evaluated, by the way. Right, it's doing 5 plus 5, but then it's being forgotten. So then we're printing 2 here. Okay, another expression we can have is, something called a string. Right, we'll talk about a string next week, but basically a string is kind of like literal text. So I'm put hello here. Right, what is the value of the last run statement? It should be hello. So I'm going to press play. Hello, right? We can add strings together, by the way. Right, hello plus world. And this should evaluate to hello world with no space in between. Okay, if you want to put a space in there, there's a few ways you can do that. You could put it in the first string or the second string, right? Or you can just add another one. Okay. Hopefully people are cool with this so far. This is a really big takeaway of Jupyter Notebooks. Last run, the last expression is being displayed here. In traditional programming, if you wanted to show the values of all of these, it would probably be useful to print all of them explicitly, meaning that I'm going to wrap all of these expressions in a print statement. Right, so this expression is an input to the print statement, and this expression is an input to the print statement. And finally, I'm going to wrap this whole expression in the print statement. Okay, and then I go ahead and press play, and there we go, right? It actually prints all of them. Okay, people cool with this so far? Okay, yeah, this is a really large takeaway. I'm probably going to repeat this again in a while. Okay. Any questions so far? People on Zoom good? Okay. Okay, nice, nice. See some thumbs up. Okay, all good, all good. Okay, let's see. Okay, I just covered these right here. I accidentally did these earlier than I was supposed to. But yes, we just did a bunch of statements with inputs inside of it. So you can try these on your own. Hopefully people see what it's going to print. The order of operations do matter, by the way. Like, let me just cherry pick this one. I'm just going to cherry pick this last one. If folks are familiar with order of operations, what do you think this is going to print? Order of operations, like in algebra class, you might have heard of PEMDAS. What's this going to print? Let's see. 100.5. If you're not familiar with order of operations, basically in algebra, this is being evaluated first. The division sign takes precedence over the plus sign. So what it's actually doing is that there's a pair of invisible parentheses here. Right? Parentheses meaning that this stuff will get evaluated first, and then it'll get added to 100. Okay. People cool with this so far? Okay. All right. Let's talk about another function. We've only seen one function so far. It's the print statement. There's another function called length as well. This is a useful function for measuring things. So the function here is the len, right? And the input can be many things. Right? For now, I'm going to use a string input. Right? We'll talk about what a string is later, but you can think of it as literal text. So what is the length of hello world? It is 11. People see that? It's 5 plus 5 plus 1. Okay, hopefully people see that. And I'm just gonna go ahead and print it. It's the same thing, but I'm gonna get in the habit of printing things just because Jupyter Notebook can promote bad practices. One such bad practice is if I were to try to print two things at once, right? Like length of hello, right? And press play here. Right, see, I was only printing 5. This is possibly bad programming practice because we forgot to print this earlier one out. So I'm gonna get in the habit of printing everything we want to see. Okay, which is also how traditional programming goes. Okay, press play, now it prints 11 and 5. Okay, this might not seem useful right now, the length function. Oh yes, question.
So it just counts like the letters?
Oh yeah, good question. Does it count just the letters? Yeah, in this case, a string, each of these have a length 1. The space, this is called a character. Everything in here is a character. Mm-hmm. So there's 11 characters in total. There are other types of inputs that we'll see in the future. So this is just text. It's like, hey, what's the length of this text? But in the future, we're going to be using length on data structures. So like, imagine, I'm kind of going ahead. Right, so let's imagine that we do some data structure here. Right, we'll cover this later, but this is going to tell us how big that thing is. Okay. Okay, yeah, good question. Okay, any other questions so far about the length function? Okay. Okay, cool. So this is an example of something called a classless function, meaning that there's no, let's see, okay, maybe, okay, this is going to come together in a bit. But I wanted to introduce something called class functions. Class functions is a different style. Basically, the style is it's some object that has some functions. Right, in this case, this is a object. Right? It's like a text object, and text objects have functions. Right? One such function is called the upper. So if I go something like hello, and then invoke, invoke means to run. So I'm going to run a class function. All right, so this is a little different style. This is going to give us hello in all caps. Right, so the difference here is that a class function has a period, and then to the right of it is something that the left side can do. Right, this might seem a little weird because you might think you can do something like this, upper, and then hello. Right? You might think you can do this, but the designers of Python didn't design it to have something called a classless function. Right? This is attempting to make a classless function, attempting to use a classless function. Right? But the designers never made this. They did make it, but it belongs in a different area of the code. Okay, this might seem confusing right now, but it's going to make sense later. However, you can look these things up, by the way. Right, you can look up Python functions. Right, like, let me look up Python functions. Right, this is going to give us classless functions. So I'm going to look for the primary source real quick. The primary source is right here, docs.python.org. Okay, so I'm going to look at documentation. Some pre-built functions, classless functions, are like this right here. We used, what do we use here? Is there a print here? Oh yeah, we use this print right here. I mean, yeah, you can click on it to see how it works. What else do we use? We used another one, length. Right, length right here. That's another function we used. And yeah, there are many more here that are native to the Python language. So these are classless functions. And going off a rabbit hole in a bit, these are class functions right here. Right? Class functions means that there's an object. The object here is a text, and a text object has many functions that are associated with it. Right, so I'm going to dive down into another documentation real quick. This is kind of going ahead of what we need to, but it's useful. Right, I'm going to Google up something called string functions. Okay, strings are text, by the way. We'll cover that next week. So I'm going to Google up something called string functions, Python. Okay. Oh, and methods. Methods is a synonym for functions. So I'm going to click on the primary documentation right here. Let's see. Oh, and then string methods over here, which is synonymous to functions. Okay, and we use something called upper. This is quite some dense documentation, but it's kind of showcasing what we can do with strings. For example, we used something called upper, which is right over here. Right, this is what we used. Right, some object string and then dot upper. Okay, so yeah, the reason why I'm showing this documentation is just to kind of show the differences on the design. Okay, let's move on a bit. We were just showcasing something called string functions. Right, these are class functions. Another one we can use is called the replace. So let me do this example right here. So I'm going to do something dot replace something. Okay, we'll talk about what the replace does in a bit, but this class function is going to modify this left side, or it's not going to modify it. It's going to modify it and then kind of make another copy of it. So if I use something like I'm not shouting, and then inside of the input for replace, the replace function is expecting 2 inputs. So on the first input, I'm just going to use another string called not, and then another string called really. All right, so let's see what this does, and we'll kind of see. Okay, so press play. This is a expression, by the way. This expression evaluates to I'm really shouting. Do people kind of see what's going on here? Right, the function is replacing all occurrences of not with the string really. Yes, question.
What would you do if you wanted to replace more items in the string than just one?
Oh, good question. What would we do if we wanted to replace multiple items? For now, with what we know, we'd have to do another, it's called a compound. With what we know so far, we could compound the functions. So this is going to look tricky. All right, so this expression evaluates to this string right here. We can actually compound things. So I could say like a dot replace, dot replaced, maybe I'll replace shouting with whispering. So this is another way we could do it. So I'm going to press play. All right, I'm really whispering. Yeah. This is just one way, by the way. There are multiple other ways we can replace multiple things at a time. In my opinion, the best way to replace things is with some sort of a loop, which we'll cover in probably a few. I'm not sure when we're covering loops. I gotta check the schedule again. But yeah, this is one way. It's called compounding functions. If you're curious what's happening here, this left side is being evaluated to a single string. So this, the thing I highlighted, this actually collapses to some string right here, right? So, something. I'm not going to type the whole thing out, but yeah, it evaluates to this, and then it'll collapse this next part for us. Okay. Yeah, that's some really cool stuff.
Thanks.
I assume they're going to work sequentially in order.
Exactly. Yeah, with the periods, yeah, it goes left to right. Yeah, I'm glad you brought that up. There's so many different ways to do things. I don't want to expose too much right now yet, though. Let me think if I can expose another way. Yeah, I'm gonna keep it simple for now. Okay. If folks are wondering what some functions do, once again, you can look at the documentation. The documentation is kind of dense, so I don't expect folks to fully read it for now. But here on the primary documentation for string methods, I could look at the string replace method. So where is it? String replace. Let's see, replace right here. All right, so it talks about what it does. It says, oh, it can take 2 inputs. Right, so we use 2 inputs, the old and then the new, and then here's some description on what it does. Okay, this is going to be useful later. Okay, let's move on. So we just talked about compounding functions. I'm actually glad you brought that up, because this next part does the same exact thing. We can compound 2 string functions. So let me do this slowly. I'm not shouting, but I'm going to replace not with really. Okay, let's do this slowly. So I'm going to run this first piece first, just the left side. Okay, I'm going to press play here. Okay, I'm really shouting. All right, so this means this whole expression evaluates to this single string, meaning that we can put another function to it. All right, so that means this part is going to be uppercased now. So press play, and I'm really shouting. Okay, so this is an example of chaining class functions. Okay, and just going off a bit, you can do it with classless functions as well. What would we do if we were to calculate the length of this whole string? Can we do a dot length right here? Unfortunately, we can't do a dot length because the designers of Python, or the designers of the string, didn't write this right here. Right? They didn't write a string dot length function. But once again, there is a native one. Right? It's the native Python one. So I'm going to put length around the whole thing, and that should evaluate to 19. Right? Okay, people cool with this so far? All right, cool. A quick tip that I haven't really mentioned yet. I've been using a couple keyboard shortcuts to press play. Let's see. So a couple keyboard shortcuts that you might use a lot is run selected cell, which is Shift Enter, or you can press Control Enter. Control Enter means to run it, but not go to the next one. So you might find yourself using those. It's just a play button. That's all it is. Okay. Okay, let's see. All right. Okay. Some compound statements. Let's see. This is a sneak peek into if statements. So I'm not really gonna go too much into detail about this. But this is just an example on, using a compound statement. Basically, there's one function here, and then we're storing that into a variable called now, and then we're checking if now.hour is something. Right? You don't have to worry about this too much. This is just a quick sneak peek. Okay, it says good morning. It's actually not morning right now. The reason why it says good morning is probably because this is using a different time zone. So let me just do a print statement to see what this variable actually is. Okay, once again, you don't have to know anything about variables, but this will come sometime next week. I'm going to do something that's like a debugging statement. A debugging statement is something that we want to visualize. So let me go ahead and visualize this now. Okay, so I'm going to print now here. I'm also going to give this function some more detail, like the time is now. A print function can take multiple inputs. In this case, I'm going to use a string and then the value from this variable. So this is going to help us visualize what's going on. Okay, so the time is now, and then it's printing right here. All right, it says it's 2:46 a.m. This is a different time zone. It's probably something called the UTC. Let me just Google it real quick. UTC. UTC stands for Coordinated Universal Time. So yeah.
So the nickname is Zulu.
Zulu? Oh, okay. Yeah, that's. How do you spell Zulu?
Z-U-L-U.
Oh, okay.
Yeah, so it's a military term. It's, we're in Tango.
Oh, okay. We're in Tango. Okay, that's some cool terms.
Tango Pacific?
Tango is so many hours from Zulu, and so we alternate back between Sierra and Tango.
I see.
We are right now, what, +9? We're UTC +9.
Oh, okay. Yeah, we're UTC +9. So let me look at the time zones real quick. If people are curious what we're talking about, we're just talking about time zones and the relative from UTC. So time zone map. Oh, I clicked this a while ago. So yeah, I guess Zulu is right here.
Yes, so it used to be called Greenwich Mean Time.
Oh, okay.
And so now it's UTC, And then in military, it's Zulu, and then they just put letters to the subsequent times. And I always have 2 clocks on my wall
Mm.
because I do radio where everything is UTC.
I see. Yeah, hope that motivates why this is in UTC. There is a way you can change this to Pacific Standard Time. Basically, you can just add a couple more arguments inside of here. Okay, anyways, let's move on. So this is giving a sneak peek into a bunch of things that we'll see later. Okay, let's talk about something called an import statement. These are for including libraries. Libraries are code that's written elsewhere. There is a library called Jupyter Turtle, which is going to help us visualize algorithms. Okay, so I'm gonna go ahead and import a library. So import Jupyter Turtle as TU. Okay, if you're curious what this means, it's saying include this library, but name it TU. That's what it's saying. Meaning that we're going to be able to refer to this in a short notation. Right? TU is the short notation that we're going to be using. It could be anything. Right? This could be anything. But this import doesn't matter. Right? This is the name of a file that someone wrote. Okay, I'm going to use TU here. All right. I'm going to use another thing too. This is a load extension. You don't have to worry too much about what load extension does. All right. In short, this line is including a Jupyter Notebook extension that will make it easier for us to visualize things. Okay, yeah, don't worry about this first line too much. This second line is more important. Yes, question?
I apologize if this is explained later, but where does it import stuff from?
Oh, good question. Where does it import stuff from? That's a really good question. It imports it from our server, which already has these installed.
So like if I were doing it on my own personal computer, I'd have to install that.
Mm-hmm.
And where would I put it then?
Yeah, good question. If you're on your own computer, how do you install this external library? One way you can do it is with some commands. So this library actually comes from a source called PyPy. So PyPy is a place where folks upload their libraries for the public to use. So Jupyter Turtle. Let's see. There we go. So Jupyter Turtle, the way we would install this locally, right? This is for folks who want to install it on their own machine, right? If our server already comes with it. Basically, on your own machine, you'd want to load up your command line and type in pip install Jupyter Turtle. Yeah, that's a good question. It's a really good question. This class, we're not working locally. This means that we're connected to the Cabrillo server, which already has everything that we need. It already installed everything we needed. Okay. Yeah. Yes. Another question.
And then beyond import, you have like as or in. What does the in mean?
The in, like an IN?
Yeah, like import this library in, and then something. It'll say like it said it above there at some point.
Oh, it did?
I was just wondering what the in meant, like where is it in?
Let me see. Hold up. Someone asking about the keyword in. Wait, set it up here.
Oh, never mind.
This
I
right
meant to say from.
Oh, okay.
From.
Yeah. There's a few different styles on importing. Some libraries have libraries within them. So in this case, it's saying from this library, import another library that's within it. You can think of it as something called a subclass. So this big library actually has multiple things, right? Like you could do something called a time delta, right? I think that's what it is. But yeah, this big library has multiple subclasses. So yeah, it's just a few different styles. However, for the Jupyter Turtle library, there's no subclasses. So it's more appropriate to use this import statement. That's a good question though. There's multiple ways on writing the same exact import statement. Okay, let me go ahead and run this. I'm going to use the keyboard shortcut, by the way. It's you can see them up here. Shift Enter or Control Enter. Okay, Shift Enter. Okay, it doesn't look like it did anything. It actually did, by the way. All right, so I ran it. There's no output, but something happened in the background. The kernel. A kernel is like a process, by the way. A kernel is the Python process that's running on the server. The kernel now has a library imported to it. Right, and if you want to dive deeper into it, this means that the kernel allocated more memory. Okay, so we just loaded more code in the kernel. And let's go ahead and use this code now. The code has some class functions. Right, you can think of TU as short for turtle. Turtle has class functions such as move. Okay, and it's going to render it and move the turtle 100 pixels. Okay, this is a class function. All right, let's move on to more. Okay, there are other class functions too, like turning. Okay, we'll cover more on the turtle in the next lesson. So tu.move 100. I'm going to do this step by step. The reason why is so I can catch bugs earlier. So I'm just going to run this first line. Right, so we're moving the turtle up 100 pixels, and then I'm going to go ahead and turn it. tu.turn 90 degrees. Right, turning 90 degrees, it's going to be counterclockwise. Basically, in this library was written to where a positive degrees goes counterclockwise. Yeah. Okay. People cool with this so far? All right, let's do an example of debugging. Debugging kind of means to observe an error and figure out how to fix it. So let's say that your coworker gave you some code and something is wrong with it. All right, so let's see. Coworker gave you this code. It's supposed to draw a square. It didn't draw a square. So why is it not drawing a square?
It's that 80 right there.
Yeah, it's this 80 right here. This is but basically, in order to draw a square, we need right angles, and 90 degrees represents right angles. So this 80 is messing up over here on this second corner. So I'm going to change it to 90 right here, and then there you go. Okay. It's arguably easier to read code if there's appropriate new lines. New lines mean vertical white space. So in my opinion, it's arguably easier if it's kind of like this right here. This is, I think it's easier to read because it's saying, hey, draw one side, draw another one, and draw the last one. And I would probably turn it one last time. You actually don't need to turn it, but it's going to put it in its original position and heading. The original position and heading was facing north. So I'm just going to leave it as that right there. Okay, people cool with this so far? Okay, cool. Any questions about this? This is the end of the first notebook. Okay. So yeah, this first notebook is aimed to help folks get ready with the basic syntax, right? Like we covered a print statement, something called strings. We'll talk more on strings in a bit. We covered expressions. Once again, a large takeaway of expressions is Jupyter Notebook will automatically display the value of the expression if it's the last line. All right, so like if I put a number here, right? Like let me just put 50 plus 50. Okay, once again, I'm gonna press enter, press play here. Right? It does evaluate it, but nothing is happening with it. Right? If I put 50 down here, right, it kind of prints it. It's not really printing it. It's displaying the value. I know it sounds the same, but it's not really printing 100. Okay. So that's a large takeaway of this. We covered statements that runs from top to bottom. Covered 2 different types of functions. We covered classless functions, which are these right here. Right? Classless functions don't really have a period. We covered class functions, which has a period, like a dot. Okay. Class functions will make more sense in the later end of semester. Later on, the very last lesson. The very last lesson is classes and objects. It should come together by then. Okay, any other questions about the first lesson? Okay, cool. Okay, let me see how much time we have left. We got 35 minutes left. Let's open up the second lesson. Before that, make sure these notebooks are saved. I don't think they automatically save. So you see this circle right here, this gray circle? This gray circle is representing unsaved changes. So I'm gonna go ahead and save it. There you go. You can do Control S as well. Yeah, okay, circle's gone, so we saved it. Okay, it's very important to save because let's say you were to do a homework assignment and didn't save it. Folks might end up downloading it. There's a download button somewhere here. It's right over here. If you were to click the download before we saved it, it's likely going to be an empty notebook, meaning that you're going to be submitting nothing. So yeah, make sure it's saved. All right, let's go on to the next lesson. I'm going to quit this and then open up this file explorer on the left again, and then navigate to the second lesson. By the way, you can navigate backwards a directory too. Like just click up here and it'll navigate backwards. In particular, I'm going to go to lessons and then the second one, using the turtle. Okay. This notebook is going to introduce more turtle functions. But the reason why we're using a turtle is so we can visualize algorithms. Okay, so let me just run this cell first. This cell is going to import code into our kernel. It's going to load code into the process. Okay, which by the way, if folks ever mess up the kernel, meaning that if you ever have an error message that can possibly mess up future things, it might be necessary to restart the kernel here. All right, so there's a kernel button, and then you can do like a restart and clear output. Right, this is pretty much saying just refresh everything, right? Like delete all of your variables, delete everything. It's not going to delete the cells though. It's just going to delete all of the stuff that's hanging in the process. So that might be necessary. Okay, I just ran this first cell, which loads the things. Okay, we saw earlier that we can draw some lines, right? The move function takes a number as an input, that number represents how many pixels we're going. So this goes up 100 pixels. We can also use negative numbers. Right here, let me run this step by step. So I'm going to press play here. Right, we can go up 100, and then we can go negative 50. Use Control Enter there. And yeah, just going backwards. Okay. We saw the turn as well, right? Like, so we can move it 30 degrees up, 30 pixels I mean, and then turn it left 45 degrees. Right, there you go, it turned left. And then, here, you know what? I'm gonna bring up a chart real quick in case folks are unaware of degrees. So let me just bring up something like a compass heading. I'm just gonna Google this up. Compass heading. If folks are wondering what those numbers, the turn numbers mean, it's kind of like this right here, but reverse. All right, so when we said turn 45, it's going to the 45 degree right over here. All right, that's what it's doing. But the person who wrote this library reversed things a bit. So 45 degrees will go counterclockwise to the left. Okay, hopefully people are getting a sense of what a degree means. Okay, so turn, and then I'm just going to put a new line here, a vertical white space to make things easier to read. Tu.move, and then there we go. Turn. Right, turn negative 45. Right, negative 45 means go clockwise. Okay, and then finally a move. There we go. Okay, people cool with this so far? Okay. Once again, the reason why I did it one at a time is to make sure things are working fine. Right, if an earlier statement has an error, the next ones won't run. So yeah, be careful. If you're typing out a program, please don't type out like 100 lines and then press play. You want to kind of build it slowly and test it frequently. There's another function that hides the turtle, kind of. I mean, not hides. It picks up the turtle, meaning it's not going to leave a trail. So let me just comment all of this. Okay, so I'm commenting that. Let's move it first. Right, there you go. It goes up 30 pixels. We could pick up the turtle. Right, so pick up. It doesn't look like it did anything. I just picked it up. I pressed play. Right. By the way, I'm pressing play with Control Enter. Right, so that's the keyboard shortcut. Okay, let's go ahead and move it now. So pen up, and then let's go ahead and move it. Okay, see what happened there? We moved it 20 pixels up, but there's no trail. Right, that's because we picked up the turtle. Okay, let's go ahead and put the pen down and then move it again. Control Enter, there we go. And now it's back down with 30 more pixels. All right, yeah, it's pretty sick. Yeah, this is really cool stuff. My coworker actually wrote this library. My coworker, Mike Matera. So credits to him. By the way, I'm going to be crediting my coworker a lot because he wrote most of this material.
I'm taking his intro to cloud computing class right now.
Oh, okay. You're taking Mike's class as well, Intro to Cloud Computing. You're in for a fun time.
Nice.
Yep. Some fun stuff. Yeah, so Intro to Cloud Computing. You might learn how this server is built. Yeah, if you're taking any other classes, CIS classes or CS, feel free to ask me for help. I'm prepared for those classes as well. So, yeah, let me know. Okay, let's move on to some more turtle functions or pen functions. Turtle is just an analogy for a pen. Okay, we can also set the color and stuff. I'm going to skip very far ahead. Folks might be wondering, do I need to memorize this? Do I need to memorize all of these functions? No, you don't. You can actually just you can actually use this function. It's called help. Help is a native function in Python that will tell us the comments that the author wrote. So if I do help and then put the object here, turtle, it's going to give us the documentation that the author wrote. In this case, the author wrote documentation that displays its available functions. Right? Like we used pen down, pen up. We used turn. We used move somewhere. There's tons of class functions. So yeah, you don't really have to memorize these stuff. You can always just look at documentation. Okay. Anyways, back to the color and with the pen. So I'm just going to do this a little slowly again. I'm going to comment everything and kind of press play. I'm going to initialize the turtle and set the width to 30. Okay, so it didn't do anything. Wait, I think I'm in the wrong area. Okay, there it is. Didn't do anything. Right, turtle is still at the origin. I'm going to go ahead and move it. So let me go ahead and move it. And then I might as well turn it at the same time. 120 degrees counterclockwise. So press play, and there we go. Right, it moves up 150 pixels, and then it turned counterclockwise 120 degrees. We did change a couple of properties in these first two lines. Hopefully people can kind of read what's going on here, right? 30 pixels wide, and then red as a color. Okay, let's do another one. Let me just set the color to green. Right, adding some new lines for readability. Okay, set the color to green. It didn't do anything yet because we need to move the turtle. So I'll move it, and I might as well just rotate it at the same time. So move and then rotate. There we go. All right, moves, and then now it's rotating, so it's facing another direction. And then let me go ahead and set the color to blue, and then do the final move. 150. Right, there we go, 150. And then finally, I'm going to do a turn, so I can bring the turtle back to its original heading. Original heading facing north. Okay, I think this is the Google Drive logo. I'm not sure though. Okay. Okay, sweet. For some graphic designers out there, there's something called hexadecimal notation. Hexadecimal notation is a way of representing colors. It's one way of representing colors. So for example, by the way, you don't have to know this. You don't have to know this at all. Red, this can be represented with RGB. RGB means red, green, blue. Right, so like, let's say you have red, green, blue. Basically, you only need red. Right, so one way you can represent this is with hexadecimal notation. You don't have to know this. It's just if you're curious about representing this. Okay, so I'm gonna go FF. This stands for the red component, and then the green component I'm gonna leave it at 0, and then for the blue component leave it at 0 as well. So red, 0 for green, and then blue. So yeah, same. Oh wait, it didn't do anything. Let me see. I got an error message. So let's see what the error message says. Let's see. Oh, hold up. My screen is kind of flickering a bunch. Sorry about that. It's not scrolling. Let me zoom out. Yeah, it's kind of annoying. Okay, anyways, if I were able to see the error message, which I can't scroll for some reason, I think my browser is glitching. Basically, I just have the formatting wrong. So it looks like the formatting is hashtag. Okay, so let me just fix that formatting. So it's a hashtag instead. Okay, and let me scroll up. There we go. Yeah, it's red. If you want to make it purple, how do you make purple from 3 different colors? I think it's red and blue. Right, so let me combine red and blue. So this is representing the red, this is representing green, and this is representing blue. So let me go FF for blue. F stands for the biggest number in hexadecimal notation. Press play, and there we go. We made purple just from combining two things. Okay, once again, you don't have to know too much about that, but that's what this next cell is kind of showing. Well, yeah, feel free to run this at home. It's not too important though. But if you are a graphic designer, this will open up a lot of possibilities. Okay, yeah, I'm just gonna run this right here. Okay. There is another way on moving the turtle. So far, we've been moving it by a certain amount of pixels, but we can also use the Cartesian coordinate system. Right, for folks who have taken a math class where you've seen an x, y axes, right, you might have seen something like this right here. I'm just going to bring up Desmos. Have anyone here heard of Desmos? Okay. If folks are taking some class, I think it's algebra, you'll see yourself using this calculator for maybe calculating slopes, maybe to visualize certain things. So this is called a Cartesian coordinate system. It has two axes, an x and then a y. Right, so that the x is the horizontal and then the y is the vertical. So if I were to go to if I were to say x is -5, and then for the y I say like 7. All right, let me see where that's at. -5 and 7. It's right up here. You see this red dot? Right, so it went -5 on the x-axis and then 7 on the y-axis. So another way we could move the turtle is by using this point. Right? We don't have to move it a certain amount of pixels. Right? That could be kind of tedious. So another way we can move it is just by kind of teleporting it. Right? It's like teleporting, but a line gets drawn between certain places. So if I were to say TU, go to -100, -100. Right, let me run this. It draws a diagonal line. The reason why is because the turtle starts in the origin. Right? The origin is at 0, 0. So when we go to -100, -100, it just goes down there and then draws a trail that led to there. Right, so go to 100 and then -100. Right, what's going to happen here? Right, by the way, it's always a good idea to sanity check things. So I'm actually going to go to Desmos and verify what these points are. So let me visualize 100 and -100. Right, this is just for the folks who aren't familiar with the algebraic x and y stuff. So we did -100 and -100. All right, so let me zoom out a bunch. All right, so -100, -100 is here. Let's see where the next one is at. So 100, -100. So 100, -100. Okay, let's see where that is. It's right here on the bottom right, meaning that the turtle should draw a line to this area. Okay, so let me press play here, Control Enter, and there we go, right? It moved to there. Okay, people kind of getting a sense of what these two numbers represent. Okay, so I'm gonna go to 100, 100. This is on the top right. So tu.go to, top right, there we go. And then finally, go to the top left. All right, people cool with this so far? Might as well just go to the origin, right? The origin's at 0. Okay, any questions about this? Just another way of moving the turtle. Okay, I prefer this way, by the way, just because it's way more precise. Okay. Another way of turning the turtle is with this set heading. Right? Set heading is synonymous to turn. Right? But the difference is it's going to kind of teleport it, right? And instead of, so here, let me comment these out. All right, so here we're setting this heading to 90. And the person who wrote this library, 90 is facing west. So it's facing west right here. Right? Okay, this might seem the same as turning 90. It is. tu.turn 90. So let me press play here. I see it's the same thing. There are some subtle differences though. Right, so let's see what the subtle differences are. Basically, set heading means immediately face 90 degrees to the left. But turn 90 means rotate 90 degrees to the left. I mean, counterclockwise. So it's a little different. We'll see what that means right now. So here, let me go up to the set heading one. Let me move it 100. And then, okay, I moved. Okay, now let me set it to 180. All right, so setting to 180, this is facing south, I believe. All right, it's facing south, so let me, boom, yep, it's facing south. And then move it another 100. tu.move. Yes, question?
Oh, no, just search.
Oh, okay, you're good. So yeah, hopefully people kind of see what's happening here. If I were to do the same exact things using the turn, it's gonna look different. Right, so here, let's kind of do the same thing, but with turn instead. So copy and paste. Right, I'm gonna replace these functions with turn instead. So hopefully people kind of see what's going on. Okay, this gives us a different one. Right, so turn is different because let me do it slowly. Right, so hopefully this makes sense right here. Right, the turtle starts facing north, and we turn it 90 degrees to the left, and then move it. Right, so this should make sense. But then this next statement, turn 180, right? It's no longer facing down, right? It's saying rotate. Let me change these comments. Rotate 90 degrees counterclockwise. Right, so then this next one is saying rotate 180 degrees counterclockwise. Right, so 180 degrees means you're making a full turn, like a backwards. You're facing backwards, right? And then it's gonna see the turtle is facing backwards, and then now it's gonna move it back to its original. Okay, hopefully people see what the difference is between set heading and turn. Right, the difference is one is kind of teleporting it, and the other one is kind of just moving it in relative where it was. Okay. Let's see. Any questions about this so far? Just okay. Let's see. Let's move on. Once again, this is just demonstrating a bunch of class functions that belongs to the turtle. We're going to be done in just a bit. Okay. The turtle can write text as well. So I'm going to hide the turtle for now, not hide it. I'm just going to put the pen up, meaning it's not going to leave a trail. Right? I'm not going to leave a trail because we're just going to dump text out. For example, there is a function called .write. This will dump plain text onto the canvas. So there we go. Just dump Python. Okay. And then let me just go ahead and move it now. So let me go ahead and turn 30. Right, turn 30, and then let me go ahead and move it. Okay, so we moved it backwards, right, negative 30 pixels. And let me just dump out some text there. So I'm just going to dump out a text called is. Right, there we go. We dumped out is. You can't really see it. It's underneath the turtle. So let me go ahead and move the turtle so we can see it. Okay, there we go. Move the turtle again, and then let me dump out one more text. Okay, fun. And then let me rotate it. There we go. Yeah, this rotation wasn't really I mean move. It wasn't really that necessary, but yeah, hopefully people will see what's going on. You can dump text out. And I think you can do in different fonts too. I gotta look at the documentation. Okay. Okay, this next stuff I'm gonna kind of skip over because it's not too important. The big takeaway from this lesson was really just invoking class functions and visualizing what algorithms can look like. Right? In this case, an algorithm is just like a bunch of statements that make something move. Yes, question.
Are we gonna have homework for tonight?
Are we gonna have homework? Yeah. There's actually homework.
Hey, what are you doing?
Yeah. Are we gonna have homework? Yeah. There's a constant amount of homework in this class.
Alright.
And actually, this is a 4-credit class, meaning I'm expected to deliver about 12 hours of work outside of class. Most people get it done in way less, but
It does feel like 12 hours, especially doing with the turtle.
oh, okay. It should be some fun 12 hours. I don't think you're gonna be spending 12 hours though. It's kind of like one of those contract things that faculty has to do. Like if you're in a 4-credit math class, they're gonna give you 12 hours of math homework outside of class. But yeah, most people don't really spend that long. I do recommend spending that long if you're really interested in this stuff. Okay, but yeah, I am required to deliver that much stuff though. Okay, I'm gonna skip over a couple more things. You can pretty much go over this yourself. So just one more function and that's it. Hiding the turtle. Hiding the turtle just means that, yeah, hide it. Right, so we moved it and then hide it. Okay, this is gonna be useful maybe if you wanna draw some things and delete the turtle later. Okay, this next stuff you don't have to worry about. This is just some fancier things, right? Just some other ways of drawing shapes. All right, I'm gonna skip over this. We'll see more on this probably on week 7 or week 6. We'll see more on this. Okay. Another one. Basically, the takeaway here is using something called a width. Yeah, you don't have to worry about this. Okay. All right. Another one here. This one is going to set a background using a picture that's located in our server. So every student here has a picture called maze.png. It's located in this directory, your labs, files, and then right there. If you're curious what I'm pointing to, it's let me just press play first. So press play. It's pretty much setting the canvas to a picture that we have on the server. So if you're curious, this came from over here, right? Dot means go backwards. You don't have to know this unless you're like in a Linux class or something. Right? Dot means go backwards. So I'm going to go backwards on this directory. Right? So go backwards. And then it's saying go to labs. So I'm going to go to labs, and then it's saying go to files. And then yeah, there's a picture here called maze.png. So yeah, you can load in your own images if you want. Okay, let me go back to the original directory though. Okay, cool. Okay, I think that's about it. You can change the shape of the arena as well using this set size. Right, it's the width and height. So if you want to make a bigger arena, you can use a bigger number here. All right. With how much time do we have left? Hold on, let me see. I don't mean to cram so much, but I do want to go over one more little thing. Okay, we have 8 more minutes left. I'm going to use this 8 minutes to show how the labs work. We just finished 2 lessons. Let me just save this real quick. So save, and then I can exit this. We just finished 2 lessons, 1 and 2. We're kind of ahead of schedule right now, which is a good thing. Hopefully it didn't feel too crammed. We finished lessons 1 and 2 meaning some of lesson 3 will leak into Thursday. Anyways, we actually have enough to get the lab and the homework assignment done. I recommend doing the lab first because the deadline is earlier than the programming project. So let me just go over the lab real quick. The lab is pretty cool stuff, actually. One cool thing about the lab is that it has like a feedback. It has a feedback bot, kind of. So I'm going to load up the first lab. Right. By the way, you just got to go backwards, go into labs, and our first lab is right here. It's a lab on algorithms. We have enough to get this done. Labs are a place where you can practice and apply the content that we just got exposed to. They consist of, it's kind of like free response questions where you type in code to solve something. So make sure you load in this first cell real quick. You don't have to worry about what this does. This is just the Jupyter Notebook extensions. We're just loading in extensions to make things look nicer. This is not really a thing in classic Python, by the way. Okay. So load these in. The labs typically look like a bunch of free response questions. Like here, part 1, right? Draw a square. So I think we saw a square earlier, right? A square consists of turn, move, turn, move, turn, move, right? Like 4 different times. So let me just go ahead and do that real quick. So tu dot move, let me move it like 50. All right, and let me just test this very slowly. Okay, cool. This is why we test things slowly. Otherwise, we get error messages. So tu is not defined. This probably means that we never imported something. So I think we need an import. Oh, it's right up here. I forgot to run this cell. So go ahead and run this cell, which will import the library into the kernel. So I'll run this, meaning that this should finally work. Okay, so let me run this. Okay, there we go. All right, so tu.move 50. Let me continue doing the square. Right, so now we gotta rotate it a right angle. Right, so I'm gonna rotate it 90 degrees counterclockwise. There we go. And hopefully people kind of see what we gotta do, right? Just move it again. All right, tu.move. Okay, move, and let me just turn it. Tu.turn 90. Right, we just gotta do that 2 more times. So I'm just gonna, there we go. And then, boom, square. Okay, we drew a square. The cool thing about these labs is that it has a bit of feedback that might help if you're having some weird errors. It's not really that helpful, but this next cell is like a feedback thing. So you can go ahead and click on this cell right here. You don't have to understand what these lines do. It's really just testing your solution, making sure that some things are being checked off. So I'm gonna press play here. Right, all tests pass. Right, so that means we're good. Right, it's kind of helpful, right? Like if I were to miss something, like let me just comment this stuff out. Let me just comment out the last 2 lines. Right, comment the last 2 lines is no longer square. So this feedback will tell us, oh, attention needed. Square should have 4 sides. So this might help. It's not going to detect everything that's wrong, but it's going to help a tiny bit. Okay, so that was the first part of the lab. Part 1, number 1. So there are some other pieces that you should be able to do now. You should be able to get the rest of this done. Okay. Once you're done with it, let's talk about submitting. So the way we submit is through Canvas, actually. First make sure it's saved. There are unsaved changes here. So make sure there are saved. All right, so save notebook, boom, saved. And go ahead and download it. One way we can download it is with file and then download. All right, so download. This is going to put it on your local machine. All right, so it's going to be, it's in my downloads folder. Okay, so once it's in your downloads folder, go ahead and go to the Canvas and then submit it. It's somewhere over here. Assignments, and then lab. All right, so this lab is due on the 29th, which is sometime from now. Okay, so lab week 1. And then submit. I think you can just drag it. Just like click and drag, and boom. It should upload it, and then you can submit it. All right, so go ahead and get those by Thursday at least, or I mean by this date. Okay. There are homework assignments in this as well. We'll talk about this on Wednesday. You actually have enough to get this homework done, but we'll talk about it on Thursday. Right? The only thing we'll talk about really is how to download this. This notebook isn't in our server. You have to download it from Canvas and then upload it. So yeah, we'll talk that on Thursday. Okay, so let's summarize what we did today and end class on time. Okay, first of all, I want to thank everyone for being here on Zoom and in person and on the recording. We just went over Syllabus Day, really, and a couple lessons. All right, so here's what we did today. I pretty much just introduced myself, briefly skimmed over the syllabus. Please read it a little more thoroughly. And then we motivated what entails the future. Right? Some folks, this is a lot of people's first computer science or computer information systems class. We talked about a bunch of career stuff and why it's important. Right? Like you might not be interested in programming, and you might be wondering why this is a requirement. Okay, we set up the development environment. Hopefully by this week, folks have set up their Cabrillo student email and is able to connect to this server. Right, please reach out to me if you're having trouble. If you're having trouble connecting to your Cabrillo student email, the last resort is to contact the CTC. Right, so you can just Google the CTC Cabrillo. They have a little more power on the logins and stuff. So you can go to CTC. They have Zoom support and in-person support too. Okay. So yeah, we set up that, and we did lesson 1. We also did lesson 2 as well. So I'm just gonna add that. Okay, thank you all. On Thursday, we'll do some more stuff. Thank you for coming, and welcome in.
Thank you.
Yes.
Thank you.
Thank you, Professor.
No problem, Natalie. Have a good night.
You too.
Finish like a year or
Technically my second, but